In this lesson, I'll show you how to integrate 1 over 1 minus x squared with respect to x. Now, if you know your integration rules, you should be aware of this rule here, which states that the integral of 1 over a squared minus x squared is equal to 1 over 2a log of a plus x over a minus x plus c, the constant of integration. Now, if we compare this to our integral, and let me write the integral here, so it's the integral of 1 over 1 minus x squared with respect to x. Well, comparing these two, I can clearly see that a, in this case, would be 1. 1 squared is 1. So if I plug a being 1 into here, that would give me the integral of my expression here. So I've got 1 over 2 times a being 1, so it's 1 over 2, log of 1 plus x over 1 minus x plus c. So this here is the integral of this here. Now I'll leave that there and we can compare it at the end, but I'm going to go ahead and do it using partial fractions. So let's commence then. So if I look at this denominator here, I've got 1 minus x squared. And I realize that that is the difference of two squares. So I can actually write that as 1 over 1 plus x times 1 minus x. So my next step is to actually split this into two separate fractions. And I can do that using partial fractions. So what I'll have is the integral of a over 1 plus x plus b over 1 minus x dx, and some brackets around here. So clearly I don't know yet what a and b are. But what I can do, I can actually compare the left-hand side with the right-hand side, and I'll do that down here. So I've got 1 over 1 minus x squared, which is equal to a over 1 plus x plus b over 1 minus x. Now I can multiply both sides by 1 minus x squared, or 1 plus x, 1 minus x. And that would give me that 1 is equal to a times 1 minus x plus b times 1 plus x. Now if I compare the coefficients of the x term and this constant here, well, on the left hand side I don't have an x term. In fact, it would be 0x plus the 1. So if I expand these brackets here, I can see that 0x plus 1 is equal to a minus ax, so I've just expanded this bracket here, plus b plus bx. So now I can compare the coefficients of the x terms. So I've got 0 here, so 0, and I've got a negative a, and I've got a b. So b minus a is equal to 0. And let's compare the constants. I've got 1 here, and I've got a and b. So a plus b is equal to 1. Now if I rearrange this, I can see that b is equal to a. And if b equals a, then obviously I can substitute in here. That would give me that a plus a is equal to 1, or in other words, a is equal to a half. And obviously if a is equal to a half, then popping that back into here, b must also be a half. So let's go ahead and pop these two values for a and b back into this here, and I'll separate this into two separate integrals as well. So we've got the integral of a, which is a half, over 1 plus x dx, plus the integral of b, which is also a half, over 1 minus x dx. Okay, so I can factor out this half in front of the integral. So I've got half the integral of 1 over 1 plus x. And factor out this half as well. So we've got a half the integral of 1 over 1 minus x dx. Now I know that this here, when we integrate, is just the log of the denominator. But in this one here, I've got this negative x term, so I need to get a negative 1 here. So if I have a negative 1 here, I need to put a negative here as well, because the two negatives will give me that positive again. So what I've actually got is a half log of 1 plus x. And I've got this negative here, so it's going to be minus a half log of 1 minus x plus the constant of integration. Now I can simplify this a little bit further. So I've got a factor of a half here, so let me just get that. So we've got a half. And with the laws of logs, when we're subtracting logs, we can write this as a single log fraction. So we've got a half log of 1 plus x over 1 minus x plus the constant of integration. And if we compare this answer to what we did before, when we used the little rule, we get the same answer.